So yesterday's class we did was clock's topic up to a certain extent. We are going to continue from that point. So please note down the question. The question is that at what time between 3 o'clock and 4 o'clock the hands of the clock will be at right angle. The hands of the clock will be at right angles. Now if you remember, we drew a diagram of the clock, and in that particular diagram, seeing that diagram, we could tell that between two particular times, how many number of times will the hours and the minutes hand will be at right angles to each other. If we recall that diagram, we could remember and recall that the clock, hours and minutes hand will be at right angles to each other once at 3 o'clock and once between 3 o'clock and 4 o'clock. So in this particular case, there will be only one time instant between 3 o'clock and 4 o'clock at which the hours and the minutes hand will be at right angles to each other. Now let us assume this is the clock and this is 3 o'clock. So for the hours and the minute hand to be at right angle to each other, the minutes hand will have to travel 30 minute spaces to be perpendicular to the hours hand, and we remember from yesterday's class that 55 minute spaces are gained by minutes hand over hours hand in 60 minutes. Thereby 30 minute spaces will be gained by the minutes hand over the hours hand in 60 by 55 into 30, which would come out to be 32 8 by 11 minutes, and thereby we can conclude that at 2 o'clock 32 8 by 11 minutes the hours and the minutes hand will be at right angles to each other, and that will be the answer. So the answer will be that at 2 o'clock 32 8 by 11 minutes the hours and the minutes hand will be at right angles to each other. So I hope you have noted this down. Now the next topic that we are going to come to is when the hours and the minute hand are opposite to each other. That is our next topic. So again we will be having a diagram, and seeing that diagram we can directly tell that between two time instants how many number of times the hours and the minutes hand will be perpendicular to each other, will be opposite to each other. So the hours and the minutes hand being opposite to each other, So this is the diagram. It is almost similar to the diagram of coinciding of the hands of the hours and the minutes hand. So this is 12, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So Now I'll be making crosses in blue mark. These crosses will represent that once between these two time instants, the hours and the minutes hand will be opposite to each other. So if I'm making one cross between 1 and 2, that means between 1 o'clock and 2 o'clock, once the hours and the minutes hand will be opposite to each other. Similarly, they will be opposite to each other at all the points. I'm making this cross with blue marker. But the important thing here is that between 5 to 6 and 6 to 7, the hours and minutes hand will be opposite to each other at 6 o'clock, and not once between 5 and 6 and 6 to 7. So the hours and the minutes hand will be opposite to each other once between 5 o'clock and 7 o'clock, and that will occur at 6 o'clock. So we can say that the hands of clock are opposite to each other, once every hour, but as we can see from the diagram, but 11 times in 12 hours and 22 times in 24 hours. Now we are going to do a question relating to the hours and the minutes hand being opposite to each other. I hope you have noted this down. So the question is that at what time between 8 o'clock and 9 o'clock the hands of the clock will be opposite to each other. Hands of the clock will be opposite to each other. Now again, let us consider the position of the clock at 8 o'clock. So this is the clock and this is the clock at 8 o'clock. This is the hours hand and this is the minutes hand. So now if we recall the diagram, then we can remember that there will be only one time instant between 8 o'clock and 9 o'clock when the hours and the minutes hand will be opposite to each other. So to calculate that, it will happen when the minutes hand has travelled 10 minute spaces and came here. When the minutes hand has travelled 10 minute spaces and came here, that is at 2, 1 and 2. So again we will apply the same thing, that 55 minute spaces are gained by the minutes hand over the hours hand in 60 minutes, and thereby 10 minute spaces will be gained by the minutes hand over the hours hand in 60 by 55 into 10, that is nothing but 10 by 11 minutes. So we can say that at 8 o'clock 10 by 11 minutes, the hours and the minutes hand will be opposite to each other. So that is the answer to this particular question. Now the next type of questions that we are going to do is that we will be given a time instant and we will have to calculate the angle between the hours hand and the minutes hand at that particular time instant. If you recall, we did a concept yesterday, and that was that every 1 minute the minutes hand moves 6 degrees whereas the hours hand moves half a degree. That particular concept will be applied in all such questions. So the question is, and please carefully see how to do these type of questions. First, the concept that will be applied here is that in every 1 minute, the minutes hand moves through 6 degrees, whereas the hours hand moves through half a degree. This is the concept that will be applied in all such questions. So the first question is that we have to find the angle between the hours hand and the minutes hand at 5:20 am. Now to calculate that, please try and see the procedure of calculating such questions. First thing that we have to understand here is that the minute hand has moved 20 minutes. Okay, and we know that the minute hand moves through 6 degrees when it completes 1 minute. So when it moves for 20 minutes, in 20 minutes, how many degrees it would have moved is basically 20 into 6, that is 120 degrees. Okay, similarly, the hours hand has moved through 5 hours plus 20 minutes. 20 minutes is nothing but 20 by 60 hours. This is 5 plus 1 by 3 hours. Okay, 5:20 am is nothing but 5 plus 1 by 3 hours. And 5 plus 1 by 3 hours is nothing but 5 plus 1 by 3 into 60 minutes. Okay, so, and we know that in 1 minute the hours hand moves through half a degree. So in these many minutes, the hours hand will move through 5 plus 1 by 3 into 60 into half degrees. That is nothing but 2, 3. This is nothing but 150 plus 10 is equal to 160 degrees. So now we know that at 5:20 am the hours hand would have moved through 160 degrees, whereas the minutes hand would have moved through 120 degrees. Thereby we can say that the difference in the angles subtended between these two will be 160 minus 120. Therefore 40 degree will be the angle between the hours and the minutes hand at 5:20 am. So this is for the hours hand and this is for the minutes hand, because the minutes hand has travelled to 20 minutes where the hours hand has travelled to 5 plus 20 by 60, that is 5 plus 1 by 3 hours, or 5 plus 1 by 3 into 60 minutes, and the angle subtended would be 5 plus 1 by 3 into 60 into half degrees, because in every 1 minute the angle subtended by the hours hand is half a degree, and therefore in 5 plus 1 by 3 into 60 minutes the angle subtended by the hours hand will be 5 plus 1 by 3 into 60 into half a degree. Similarly, the next question is we have to find the angle between the hours and the minutes hand at 3:40 am. Now again, let us first find out for the minutes hand. Now minutes hand has moved through 40 minutes. Okay, so now we know that the angle subtended by the minutes hand in every 1 minute is 6 degrees. So in 40 minutes the minute hand will subtend an angle of 40 into 6, that is 240 degrees. As far as the hour's hand is concerned, it has moved 3 hours. 3 hours is nothing but 3 into 60 minutes plus 40 minutes. That is nothing but 220 minutes. And we know that in 1 minute the hour hand subtends an angle of half a degree. Therefore, in 220 minutes the hour hand will subtend an angle of 220 into half. That is 110 degree. And thereby we can say that at 3:40 am the angle between the hour's hand and the minute's hand will be 240 minus 110. That is nothing but 130 degree. Similarly, we will do one more question of this particular kind. So the question is that we have to calculate the angle between the hours and the minute's hand at 2:37 by 11 am. Okay. Now 37 by 11 minutes is equal to 40 by 11 minutes. Now again, as far as the minute's hand is concerned, it has moved 40 by 11. It has moved for 40 by 11 minutes, and in every 1 minute the angle subtended by the minute hand is 6 degrees. So in 40 by 11 minutes the angle subtended by the minute's hand will be 40 into 6 by 11, that is 240 by 11 degrees. As far as the hour's hand is concerned, it has moved for 2 hours, that is nothing but 2 into 60 minutes plus 40 by 11 minutes. This is the total minutes that the hour's hand has moved through. In every 1 minute the hour hand subtends an angle of half a degree. So in 2 into 60 plus 40 by 11 minutes, the hour's hand will subtend an angle of 2 into 60 plus 40 by 11 into half degrees. This is nothing but 120 plus 40 by 11 into half. This will be 60 plus 20 by 11 degrees, and this 60 plus 20 by 11 minus 240 by 11 if we do, then we will be able to calculate the angle between the hours and the minutes hand at 2:37 by 11 am, and this will come out to be equal to 40 degrees. Now the next type of question is that the angle between the hour's hand and the minute's hand will be given to us, and we will have to calculate the time at which the angle between the hour's and the minute's hand will be equal to the given angle. So we have to calculate at what time between 2 o'clock and 3 o'clock the angle between the hours and the minute's hand will be 40 degrees. Now the concept that is to be applied is to be same. Let us assume that at 2:x, that is 2 hours and x minutes, the hours and the minute hand angle is 40 degrees. In that particular case, x minutes is nothing but x into 6 degrees is the angle subtended or angle moved by the minute's hand, that is 6x, and as this is for minute's hand, and for hour's hand, in 2 hours the hour's hand would have moved through 2 into 60 is the minute, 2 hours is nothing but 2 into 60 minutes plus x minutes, and 1 minute the hour's hand moves through half a degree, so in 2 is to x minutes, so in 2 into 60 plus x minutes the hour's hand would move through 2 into 60 plus x degrees. Now the angle between the hours and the minute hand at 2 is to x is 40 degrees. Now that angle can be 2 into 60 plus x into half minus 6 by x, or that angle could be 6x minus 2 into 60 plus x into half. So we will write down both the cases, that is either 6x minus 120 plus x by half is equal to 40 degrees, or the other cases that 120 plus x by 2 minus 6x will be equal to 40 degrees. Now if we calculate this particular equation, then we will obtain that from here we will obtain x to be equal to 18 2 by 11 18 2 by 11. So the time instant at which the hours and the minutes hand will subtend an angle of 40 degrees in between 2 o'clock and 3 o'clock, one such time will be 2 is to 18 2 by 11 minutes, that is 2 is to 18 2 by 11 am, and the other time can be calculated from this particular equation, and when we calculate it we will find out that it will come out to be equal to 3 by 11 minutes. Therefore the other time instant at which the hours and the minutes hand will subtend an angle of 40 degrees between 2 o'clock and 3 o'clock is going to be 7 by 11 minutes. So these are going to be two answers. Now as far as the question is concerned, that why we have obtained two answers, because if you recall the diagram that we initially made, then there will be two such time intervals between 2 o'clock and 3 o'clock at which the angle subtended between the hour's hand and the minute's hand can be 40 degrees, because this is 2 o'clock and this is 3 o'clock. Now between 2 and 3 the angle subtended between by the hours and the minutes hand could be 40 degree like this, or it could be 40 degree like this. This could be 40 degrees or this could be 40 degrees. That is why we will have two answers in this particular question. There is also a direct formula which we can use to find out the time at which the angle subtended will be equal to a certain value given in the question, and the formula is that the required time is equal to 2 by 11 30x plus minus a, where x is the initial time and a is the angle subtended between the hour's hand and the minute hand. Now the benefit of this particular formula is that we will not have to form two equations and solve them. We will directly be able to obtain the minutes at which the hours and the minutes hand will be subtending that particular angle. So for example, the question that we just now did, we had to calculate the time instant between 2 o'clock and 3 o'clock at which the angle subtended is 40 degrees. So the initial time was 2 o'clock, so x will be 2 and the angle subtended will be 40 degrees. So if we substitute in this particular formula, we will get 2 by 11, 30 into 2 plus minus 40, that is nothing but 2 by 11, 60 plus 40, or 2 by 11, 60 minus 40, that is 2 by 11 into 100, or 2 by 11 into 20. So from here we will get 18 2 by 11 minutes, and from here we will get 3 7 by 11 minutes, and these two were also the answers that we obtained by forming the equations and then solving the question. Now the last type of question in the clock topic is fast clock or slow clock. So we are going to do them now. So the question is, we will do the concept of fast clock and slow clock using the concept, using a question. A question is, a clock is set right, a clock is set right at 9 AM and the clock will gain 5 minutes and the clock will gain 5 minutes in 12 hours. We have to calculate that what is the correct time. What is the correct time? What is the correct time when it shows 3 PM on the next day? When it shows 3 PM on the next day. Now the concept of doing this particular question is that we have to understand that in every 12 hours the clock is getting 5 minutes faster. So what we can say is that in 12 hours and 5 minutes of incorrect clock will actually be equal to 12 hours of correct clock. Okay. We can say that 12 hours and 5 minutes of incorrect clock is equal to 12 hours of correct clock. Now, as per the incorrect clock, the amount of time that has passed is 9 AM from one particular day to 3 PM on the next day. That is nothing but 9 to 9 is 24 hours, and then 9 to 9 is 24 hours plus 3 hours is 27 plus 3 hours, that is 30 hours. As per the incorrect clock, 30 hours has passed. Okay. So 12 hours and 5 minutes of incorrect clock we know is equal to 12 hours of correct clock. So 30 hours of incorrect clock, 30 hours of incorrect clock will be equal to 12 upon 12 hours and 5 minutes in terms of hours can be written as 12 plus 5 by 60 hours into 30 This is nothing but unitary method that we have applied. That 12 hours 5 minutes of incorrect clock is 12 hours of correct clock. So 30 hours of incorrect clock will be 12 upon 12 plus 5 by 60. That is nothing but in hours form 12 hours and 5 minutes into 30. When we solve this, we will find that this will come out to be equal to 47. When we solve this, we will find that this will come out to be equal to 864 by 29. Now, if we divide 864 by 29, then we will get 23 by 29 hours. This is hours. And if this is hours, then 29 is complete hours, and 23 by 29 hours is nothing but 23 by 29 into 60 minutes, which will come out to be equal to 47, 17 by 29 minutes. And therefore, we can conclude that 30 hours of incorrect clocks will actually be equal to 29 hours, 47, 17 by 29 minutes of correct clocks. And if we add 29 hours, 47, 17 by 29 minutes to 9 AM of one particular day, we will get nothing but 2 PM 47, 17 by 29 minutes of the next day. So the correct answer is going to be, that when the incorrect clock is showing 3 PM on the next day, then actually the correct time is going to be 2:29. The correct time is going to be 2:47, 17 by 29 PM on the next day. So I hope that I have been able to very clearly explain all the questions and the concepts of the topic of clocks. If you like the video, please click like, subscribe to my channel, and comment below that which topic you would like me to cover next. And thank you.